section D. This is lab 7, interference, and our TA is Wong Lei.
So we know.
Wait, do it again.
Hi, I'm Ashley.
Okay.
Hi, I'm Lucas.
The goal in section A was to determine the distance between the slits by knowing the fringe spacing. So with our small percent error, we can tell the boss that we will accept the information, and we think that sources of error in this section might have come from inaccuracy in the rail and just personal reading issues.
The goal of part B was to determine the wavelength of the light by measuring the interference fringe spacing.
So the data that we obtained for this graph shows that the wavelengths was 15.6 nanometers, which is obviously off from the actual value of 632.8 nanometers. This was another group's data who actually got a good experimental result, 621.2 nanometers. One source of error in this experiment, the biggest source was this guy right here, the little d measurements. To fix this, we could buy better equipment or do interferometry on this mirror to make sure that the mirror is completely flat.
Our goal for this experiment was to watch how water waves interacted with each other with changing frequency,
Oh, because there's an
and whether they were in
D
phase or out of
here.
phase.
Is that what you're saying?
Go.
In section C, which was the 2-point interference, our first task was to compare the fringe lines that we drew with the theoretical curves, and what we found was that our drawings were more circular, and we could clearly see circles coming together, whereas the theoretical were more ellipse-like and had lines that were interfering.
So with the more separation that you have between them, you can see how more of the circles overlap, but as you decrease the frequency, you can see fewer and fewer overlapping between the circle.
When the waves are in phase with each other, the square of the electric field is going to constructively interfere, as you can see right here, here, here. When we phase shift them, they all move left because the constructive interference will all move left by and half the intensity field will move left by half a fringe.